Smart pack wheels together. Hey guys, yeah, I'm sorry. I got here and I couldn't get into my classroom. Let me show you what I'm doing right now. Can y'all hear me? I hope so.
Yeah, we can hear you.
Yeah, I can
Okay.
hear you.
All right, I'm sorry about this. I made arrangements to be able to do this from school, but the classroom wouldn't let me in. And then when I finally got into the classroom, it was empty, no desk, no chairs, no podium, no anything. And so I couldn't set up in there. And so I had to find another classroom. And so I had to go pick up my stuff, and that's what I'm doing right now, going back to the classroom. And getting into the internet was a little tricky. So I guess I should have planned earlier. And the freaking lights don't work. Oh, there we go. I just had to walk inside. Get the motion detector running. Okay. Yeah. I was afraid of this. Yeah, I meant to get here early enough to set up all my stuff. Get everything running. So get it running like I do from home. But unfortunately, the best laid plans of mice and men. So there's a couple more things I need to grab out of here. Getting set up. The first class of the first day, and I just was not as prepared as I should have been. Anyway, this is not indicative of my normal class time. Let me tell you that right now. So I'm getting everything set up. Go about introducing myself a little bit here. Y'all see my face here. Technically, I'm supposed to have this on when I'm on campus. And I'll slip it back on here in a minute, but right now, a little out of breath. My name's Thomas Reed. I've been a math teacher for 31 years now. I don't know. Taught high school for 19 years and secondary. I spent 2 years teaching at Mark Twain Middle School in San Antonio School District. And I can honestly say I've done my time in hell. There is a purgatory, that was it. Since 2010, I've been teaching for Alamo colleges. I started out teaching at SAC, and I taught at SAC for 9 years, and I've been here since then. I started, hold on a second, get this plugged in. Here we go. And let me see here. Okay, can y'all hear me? Switch to my other microphone. Sorry, this morning is going to be a little disjointed simply because things did not go as planned. And that's something I should plan for in spite of. Uh-oh. Hi, it switched to my other camera. Hang on a second. And my main thing here is at this stage of the game is to let y'all know that despite signs to the contrary, I do know what I'm doing. Zoom has thrown everybody, this epidemic has thrown everybody into a tizzy as far, oh, fucking hell. Sorry, didn't mean to cuss. I left something at home. I'm here to help you understand this stuff. This is a pre-calculus class. It's pre-calculus 2412, sections 003 and 005. About 7 or 8 of y'all are in the classroom version, and the rest of y'all are in the Zoom the remote version. And I think I did it correctly because I think everybody's here. It looks like, well, most people are here. Let me see what's going on in chat. Okay. One of the things, I haven't set this up yet. Again, I apologize for this. What I need y'all to do is type your name in the chat, post your name in chat, first name, last name, as it shows up on the roll. That's how I take roll every day is you type your name in the chat, and that way I know who's been here. I also want everybody to have their cameras on as much as possible. Understand there's issues. If you have issues with that, email me why you're not able to be on camera as much as I want you to be. Got to look at my ugly mug. I expect to be able to see your pretty face. What else was I going to say? Oh, yeah. I'm not here to beat you up with the mathematics. I'm here to help you understand it well enough so you can go on into calculus. If you have issues, any issues whatsoever with the material or how I'm presenting it, do not hesitate to ask or to tell me in chat or you can unmute your mic and tell me, ask a question. And that's the main point of my little discussion here is if you don't understand, ask. If you have a question about what's been said, how it's been said, what it means, if you just need me to go over it again, then ask. That's what I'm here for. I'm here to help you as much as possible. Another thing I want y'all to be able to do is to form groups. Um, I know if you're in class, it's easier to form groups than if you're on the remote. I know in remote, a lot of my classes had issues with forming groups. I had one student one semester who was very enterprising and set up an Instagram group. So there are ways to do this. In Canvas, I'm going to have a discussion set up. Let me see here. There it is. Doesn't work. 8 touch pads. 8 touch pads. So I got my little mouse out. So what I'm doing right now is I'm getting some serious lag here, I think, because here we go. You should be seeing my screen right now. This is my home page. There's one discussion open, and if you go in there and look at that, it's entitled Open Discussion, and it's just basically please post questions, comments in this discussion that you may have about course or its management. Open this thread. Oh, this thread isn't, oh, there's a typo. I hate typos, my typos. I don't care about anybody else's. If you have a typo, that's fine. And to discuss anything and everything concerning this course. Keep all things here civil. The reason I put this last phrase in here, I had a class where I had 2 people who, fortunately, there was a person between them. They both sat in the front seats, but there was a person, no, they were 2 seats away from each other. So there was 2 people in and they hated each other. And thank God they had enough civility in them that it never came to blows in class, but they had similar problems and they had similar attitudes, and they were too much alike to ever get along. So, and they all had the same questions. They all had the 2 of them had the same issues every time. And so, you know, they'd roll their eyes at each other when the other one spoke. But that's why I put this here, keep all things civil. Because there's no need to get into personalities there. Oh, I just noticed there was. But let me see. Y'all have any questions for me right now? Let me go ahead and stop the share. Haven't gotten into the class yet, but of course.
Professor Reed, my name is Christine Pettis. I'm sorry
I have
was
not
late.
set up my math lab yet, or my lab math yet. I still call it my math lab, because that's what it used to be called. But Pearson reorganized it, and now it's my lab, and then the subject name afterwards. So it's weird, but I had to do that. What else was I going to do here? Well, because of the nature of the game, everything got all screwed up on me this morning. And y'all are suffering the price of it. I'm having to get organized while y'all are sitting here. I noticed someone came in after I made the announcement to put your name in the chat. first name, last name as it appears on your ACE's name. Try and avoid nicknames. Please be aware that somebody might have the same name as yours. Okay, so next thing I need to do. Oh, I did start this. Here we go. Yeah, give me a moment here. I'm sorry about this. For those of you who came in late or later, I had to what's the word? Things messed up on me this morning, and so I have had to scramble to get things going on time, and which I didn't do, and so I'm having to get organized while y'all are watching me try to get organized. And for this next bit, I have to do. I have a second screen that I work off of, and it helps me with doing the Zoom and doing the my PowerPoint and my other presentations, and so I have to get it set up. And if things had gone perfectly this morning, I would have been able to do this all in before I got here. So, I mean, before class started, but because I had other issues, like getting into the classroom. All right. This, I'm going to have to do this. Yeah, what y'all don't see me doing behind the scenes is I'm getting my PowerPoint up and ready to go. Yeah, something else I just remembered. Yeah, that's what I also do. Go through the syllabus. And so let me pull that up while I'm thinking about it right now. My syllabus is incomplete in that I have not gotten the schedule of class dates or the schedule of the material we're going to cover and the dates of the exams. And there's three class exams and then the final. And I'll discuss that when I pull up the syllabus, if I can get to it. Come on. I haven't, no, didn't do it here. Where's classroom course syllabus? Okay. I usually rearrange the what do you call it? The menu in Canvas. I rearrange it to my liking, and so where things so the order here is, instead of the course syllabus being way down here, it's going to be up here right after announcements. So it's easier to get to. The textbook is Michael Sullivan. I'm sure some of y'all found out you don't buy the textbook. All the material is provided for you. For your tuition included the cost of the book and MyLab. What I want to do right now is go through the course policies. Oh, I haven't. Yeah, I may change this. First week expected actions, miss these or one or more, is reason for withdrawal from the course. Attend class the first week of classes. Complete at least 2 assignments by, oh, well, there's going to be some issues there. I have to get that done. The reason I'm having problems with it is that they changed the process for getting my math assigned, and I'm having issues with it, and that's my fault, y'all. So. Yeah, having connection issues is part of the game. If you get dropped and come back in, you don't need to let me know in chat. Just shoot me an email saying that you're having issues or that your cable provider was being an asshole. So the method of measurement, your class exam average is 60% of your grade. Quizzes and other assignments is 10%. And then there's a comprehensive final. That means everything from today till the day before the final will be on the test or is potentially material for being on the test. It's still hot. This is the standard grading levels. I also had taught at Incarnate Word. They have an A minus, a B plus, B minus, a C minus, or a C plus C, and then a D plus, D minus, and then just F. So they have more grade levels here than what we have. And it also goes in differently as in the grade point. So each, whether it's an A or an A minus, if it's an A, you get a 4 point. If it's an A minus, it's a 3.75, I think. I don't know. It's not the whole 4 points. And so, yeah, it is something new to me when I started teaching there. Homework is assigned through MyLab. You're responsible for keeping current with the homework. There's the homework average will be used to make up points. In each exam, not an each exam. I don't know. I hate my typos. Quizzes may be announced or unannounced. I may just decide I want to do a quiz today. And so if you're not here for that day, then you missed out on the quiz. There'll be 3 exams and a comprehensive final. How this average of the homework, let's say we covered a chapter and a half, then the homework for that chapter and a half, the average of those homeworks will be used as up to 15% replacement points, up to an 80. So if you made under an 80, then the homework grade can be used to replace missing points up to an 80. So if you made a 75 and you made 100 on all your homeworks, all you can get is an 80.
So, and I feel like if you do the homeworks and you made 100 on all your homeworks, then you should make at least an 80 or better. If you don't, then we need to have a discussion to find out what happened. Because doing the homework and doing well on the homework should mean you should get a decent grade on the exam. So yeah, the test dates will be decided, to be announced. I've already gone through some preliminary work on figuring this out. I divide the semester into thirds, actually into thirds. Yeah, thirds. So it's not dependent upon what chapter we finished. It's how far are we in the book at this point in time. The second exam is around where the people who give midterms, it'll be around that time. It's not exactly a midterm. And then exam 3 will be a week, at least a week before the final week. I like to have the last week of classes to be review time for the final. I like to do reviews before each exam. So if you don't see it on the review, it will not be on the test. And you will get a review sheet. I'll post it in over here. There's files. I haven't set them up yet. You could see that little. That means you don't see it yet. But I'll set up things in here. There'll be files over here, exams and handouts and other things. For this course, there's a lot of handouts I give. Because we deal with the unit circle and some other fun stuff. So let me go back to the syllabus. If y'all have questions for me while I'm doing this, don't hesitate to ask them, or if you have a comment or something, please don't hesitate. Learning is a collaborative effort. Reaching to get my drink. My coffee is still way too hot. Here we go. Something sticky all over my mouse wheel. Oh, now it's really flying through. Okay. Oh, this statement here is very important. In general, I don't do makeups. You miss an exam or quiz, then you miss the exam or quiz. Missing 2 or more exams is grounds for withdrawal from the course. If you miss 2 exams, your chances of being able to pass the course drops dramatically. The average on the homework prior to each exam will replace up to 15 points. Okay, so that's whatever's each exam. Exam 1 will cover everything I go over today till that exam. Exam 2, what's on exam 2 is that the first day after exam 1 until exam 2. So it only covers that material that we've covered new since that exam. And so that's I've had people that were concerned about that. I have been known to throw in a question or two about prior material. So that's something to be aware of. But it's material that you definitely will see on the final. So it's stuff I think is vitally important for calculus. This statement is from when all my classes were in the classroom, but I feel like it's important enough to keep it there. All electronic devices, books, notes, will be kept secure in backpacks or purses during all quizzes, tests, and exams. Purses and backpacks will be stowed under the desk during all quizzes and exams. For remote sections, these items are to be absent from the work area. I know it's hard for me to be able to monitor that because all I have is that little rectangle of view. But oh yeah, see down here, lockdown browser, that's what we're going to use too. Last semester, it became very apparent that there was rampant cheating going on well, I only had one class last semester. Because a lot of students had, not only were there on my exams through the remote classes, you are to, if there's a single answer, a single item answer, then you type the answer in on the screen, in the test on the screen, but you do all your work on paper that you scan in. Either you take a picture of it and put it in well, however you can scan it in. You can there, if you have a smartphone, there's an app by Adobe. Did I put my phone? Leave it in my car. Oh, well, I can't. Adobe Scan is what it's called. Adobe Scan is a very useful tool. It's both in Android and Apple phones. It's a free app, and you just take the pictures and then you if you have multiple pages, you take the picture and then it'll say scan the next, and then you scan all the different pages, and then you save that to post, and there'll be a section where you are to post your responses. And so I don't know if you can hear me whistling. Yeah, that's because my wonderful teeth are oh, come on, damn it. These aren't my teeth. My teeth are I have all my real teeth in a bag, and they are so rotted through that I had to get new teeth. I did those denture implant things, and so it's made eating interesting. Anyway, I lost 15 pounds since I put them in, got them put in. But anyway, yeah, daily attendance is taken, is not used as a grade, but aids in assessing grades. So if you're doing poorly and you've been absent a lot, then that informs me that that might be the issue, not that you're not understanding the material, is that you're missing material. And so if you do miss a class, I record everything through Zoom, and I will have a YouTube channel for this course that I will post the channel in announcements. So either later the same day or the next day, the video will be posted. So if you missed something or you were absent that day, then you can still view it. Now, viewing the video and not coming to class does not count as attending class. So you'll still be counted as absent, even though you saw the video. So don't miss class. There's too many missed opportunities that way. What else? think here. Okay. Syllabus. Yeah, in grades, I haven't set this up yet. This class, I had a different class at this time. It was a 14-14 class. But right before I got assigned this class, that class only had one person in it. And that was 3 weeks ago. So that class obviously did not make. And so here I have, yeah, it's got all y'all here. And notice it lists everybody's name that's in this class, whether you're in section 005 or 003. So it delineates here. But from your point of view, you will be seeing, let me see here. Go back here and go to student view. I should have done that from the beginning. And grades here. And so there's nothing here yet because there's no, yeah. So there's no assign, and everything will be here is what the grades will be. And as far as due dates in the homeworks, in my lab, I will kind of estimate where I expect us to be at the end before the next test, and I'll have all the due dates be at that time. I'm a firm believer in allowing people to work ahead. So all the homework from day one to the end of this, for all the sections, even the ones we may not get to, will be open. So the section we're working in, you're getting it, boom, you work through the homeworks, and then you got it down pat. You can move on to the next section if you want to. And another thing about the homeworks, you work through the homework, you made a 70, you said, well, I didn't understand that part, but I understand it now. Well, you can redo the homework. You're not penalized for redoing the homework. I'm a firm believer in you did that. It took me a long time to understand why this math teacher had this sign up in their room. Mathematics is not a spectator sport. The best way to learn math is to do math. The best way to do math is to do the homework. That's where the learning happens. All through college, my math professors would assign homework and never take it in. And so some people go, well, why should I have to do it? Well, because that's where you learn it. My undergrad degree is in geology, and one of my geology professors said that you have to hear something 5 times for you to remember it. And so for a while there, I started listening very closely to his lectures, and he would repeat things 3 or 4 times in class. So he'd be explaining a concept or something. He was a mineralogy professor, and talk about this chemical property or how this mineral forms, and he'd go through the process at least 2 to 3 times. So hearing it multiple times, doing it multiple times, doing it with someone else and comparing notes multiple times. When I was in college, when I went back to school and picked up all my math hours at UTSA, there was this group of people that we just kind of happened. It wasn't it was just kind of organic how this thing formed. And if I did not have this group, the core group was about 6 people, and that was the smallest the group size ever was. And the largest it got was about 15 people. But we were all taking about the same classes the same time. We may have been in a different section, but we had the same professors. And my grade point average, well, my grades per class were 5 to 10 points higher than if I didn't have that group. I was a student who made A's, B's, C's, and sometimes a D. And I went from that kind of a student to being an A-B student with sometimes a C. And the C's I made were in classes I didn't have the group. So groups are vitally important to learning or that interaction. And that's why I like I'll set up a discussion group. If you got a few people, even just one other person that y'all want a discussion group online in Canvas, I'll set it up. And if I have 3 or 4 or 5 little discussion groups that separate groups of people want, I'll do that. If you want to set up like that one person I had in one class who did that, set up Instagram groups or Facebook groups for discussing things. So if you have a friend who's in the Zoom class, you won't miss out. Okay, so you can do it that way. I've never been involved in setting up groups because I think that's more from y'all's point of view rather than me saying, okay, you are a group and you are a group. That's for classwork. That's not for study. For study, it should be more organic than that. I taught a calculus for business class one semester at SAC, and at one or two classes before an exam, I had one student would stand up, the same student, she would stand up at the end of the class and said, okay, we're going to meet at this time at this place. Who's coming? So they just did something like that. However you want to do it, that's, if I can help, I'll help. But I really feel groups are vitally important and can really help. It's important that you know how to do this stuff. A lot of this stuff you'll go, well, why the hell am I learning this if I'm not going to use it in calculus? Because a lot of this you use in calculus, but a lot of it is groundwork that you build on in calculus. And some of it you might touch on in calculus, but it's not calculus 1, it might be calculus 3 or calculus 4 before you see it again. And so it is important stuff. And or you go into differential equations for those of you who are possibly are engineering majors. Differential equations will be the bane of your existence, but they're your bread and butter. And so a lot of this stuff goes over. One of the differences that pre-calculus has from other courses is that it's a shotgun class. It's not linear. It's just, all right, we're going to do the unit circle, and then we're going to do trig identities, and then we're going to do vector stuff, and then we're going to do the binomial theorem, and then we're going to do all the conics. There's no thread through it other than it's all lumped together in this course called pre-calculus. Some of it's analytical geometry, some of it's elementary analysis, a lot of it is trigonometry. And so that's the headache that is pre-calculus. All right, I've been rambling on for close to, well, I didn't start exactly at 8, so about 40 minutes now. If y'all have any questions, if you can't think of anything right now, don't hesitate to email me. Email me either through Canvas, the Canvas email. I use the Canvas email a lot, or through ACES. Either way. ACES gets a quicker response than through Canvas. You email through Canvas, through ACES, and I get a note every time I get an email, an ACES email, I get a notification on my cell phone, which I left in my car. So it's just, but Canvas, I have to check online, although I do have that Canvas app on my phone, and I need to get in the habit of checking that every day now. I think I covered about everything I wanted to cover, other than getting into the meat of the matter. Geez. I have to do something here because my PowerPoint isn't showing up the way I want it to. So, because my display settings aren't. There we go. One. There we go. There we go. Had to tell my computer that I have 2 screens, not just one. There we go. All right. Now, the next thing I need to do. Sorry, this is stuff I normally would have done getting things set up before class, but it's not doing it the way, there it goes. And where's the Zoom? There's the Zoom. Y'all are thinking, come on, old man, what's going on? Well, there we go. Y'all have
this single screen, right? You got my screen up there, right? That's embarrassing. In the process of setting everything up, I forgot to plug my computer in. So we know my battery life is about an hour. When I have everything plugged in. And I didn't lose anybody while I was gone. Okay, good. I appreciate that. Okay. So now let's get, now I gotta set everything back up again. God damn it. Yeah. Wait. Storage. That. Yeah, I'm sorry about this. Yeah, first day mistakes. Okay. What not to do first day of class. And that is screw everything up.
All right, now where did I put all that shit? Is it here? Yeah, there it is. I'm sorry about this, gang. Okay. And the next thing I need to do is bring up the camera. I got two cameras, so that's why. Come over here. This over here. That explains a lot. All right, I'm just about ready. My security program on my computer gives me notifications telling me what devices are using my cameras and my microphones. And when it pops up, there's a little button I can push and will gives me menu items, so I can decide. You have to go over here. A little menu item, so I can turn off the notification. Unfortunately, in the process of turning off the notification, there's also right under it a oh, I'm up here now. There's a option to block anything from using my camera. Well, I accidentally hit that during a I was at a Zoom conference 2 weeks ago, and during the last 2 hours of it, my camera was gone. So all I would see on here is just a black screen. Everything else worked fine. It's just no camera. And it took me almost a week to figure out what had happened and change that setting. And unfortunately, now, can y'all read that? Y'all can see this?
Yes, sir.
Yeah, because the glare is so bad in here. I can't see if you can see it. And I've got new pins to bring, but I couldn't find them before I left the house, and so have to use what was here, and this is all that was in here, was this lousy green. Okay, so we're gonna start now. And talking about trigonomic functions is the same textbook you used in if you were at PAC. It's the same textbook you used in college algebra. And come on, you're supposed to. Okay, so it's not working. All right. All right. So section 6.1, we cover most of chapter 6, and then we go into, do we do chapter 7 and 8? Yeah. And then we jump into another, I don't know where we go from there. So we're going to talk about angles and degree of measure. Angles are a shape. They're a thing. This is an angle. And we can talk about its degree of measure. So what part of a circle is it? All right, and whoa, now it's working. My little thing here. Okay, and now we're going to convert between, all right, we're going to convert between decimal and degree, minute, second measures. All right, so yeah, you have something that could be 70 degrees, 30 minutes, and 59 seconds. Oops. So the mark for a foot, like 30 feet, 59 inches, although you wouldn't have 59 inches. So that's how they work. And so what is this in as what would it be in decimal degrees? And so that's what they talk about, converting back and forth between the two. So let me. So if I just did 30 degrees, 30 minutes, yeah, it's degrees, minutes, and seconds. Sound familiar? Yeah, it is based on time. 60 minutes is 1 degree, and 60, am I still in the picture? Okay, 60 seconds is 1 minute. So 30 minutes is half a degree. And we're going to talk about how to convert between those. I don't know how much time I'll spend on it, but you'll definitely have homework on it. And then find the arc length of a circle. Convert from degrees to radians and radians to degrees. So as you know, yeah, I'm such a great artist. You have 0 degrees and it goes all the way around to 360 degrees. And as we know, a circle, the circumference of a circle is 2 pi r. So 360 degrees is 2 pi because that's going all the way around. And so based on that, you have 180 degrees over here, which is half a circle. So half of 2 pi is pi. And so we're going to be able to convert between degrees and radians. Radians are in pi, or it's a decimal number, 3.1415 times whatever. But we typically use the pi symbol. We don't use the approximation of pi. Then find the area of a sector. A sector is defined by a portion of a circle defined by an angle. So we have this angle. We usually use the Greek letter theta when we talk about angles. In mathematics, we use Greek letters to describe certain things, like pi describes a certain number. One exception is the letter E, which I'm sure y'all have dealt with. This number is approximately 2.7. There's more decimals there, but I don't know what they are. 718, I think. Anyway, it's a number I really don't worry too much about. Where we use it's an irrational number, just like pi is, and we use it a lot in mathematics. When you get into calculus and higher mathematics, you'll see E a lot, especially in differential calculus. Differential equations. Find the linear speed of an object traveling in circular motion. So it's like when you have like the original slingshots that they did like this with, and then let go when they had two thongs coming up, and with a saddle down here that they put the stone or whatever that they were throwing, and they'd swing it around and let go of one of the ropes. And what's that speed as it's traveling around, and what's the speed as it's released? Okay. So now we're going to start talking about angles and degree of measure. When two rays are drawn, and like I had done up here earlier, I don't like their stupid erasers. They end up turning my hands all black. So I got my blue fuzzy eraser, and it does a better job of erasing anyway. It's got the microfibers. Anyway, you have two rays. A ray is half a line. That's one way of thinking of it. And when you have it where it has a beginning point and it goes in one direction. So if you have two rays that have the same beginning point, they form an angle. And in high school geometry, the angle we talked about was the angle in between the two rays. We had talked about this angle in high school geometry, but here we will talk about this angle because direction is important. Okay, so which direction are you going in? All right, are you going around this way, or are you just going that way? This is a shorter distance, so this arc here is going to be shorter than this arc out here, and that'll barely show up. Okay, so we call a ray one side of the ring the initial side. So in mathematics, when you have the unit circle, you have the coordinate plane, or you're doing polar coordinates, which we will end up doing. This is the x-axis. The ray going to the right is the zero angle. The ray going to the right gets the 180 degrees. So this is 180 degrees. And in high school geometry, we typically dealt with all these angles in here. And we didn't include these angles, like going this way, and this would be 270 degrees. So this would be the initial side. And we have this angle here, So this is the initial side. And this is terminal. So that talks direction. So if this is my initial and this is my terminal, then this angle here is more than 180 degrees. It looks to be about 315 degrees or thereabouts. All right. Now, if the rotation is counterclockwise and the angle is positive, so this would be let's say this is 315 degrees. And so we call that positive, but if I'm looking at it coming this direction, then I'm going to say it's a negative 45 degrees. So whether it's positive or negative denotes direction. If you've had me as a teacher in the past, you'll hear me say that a lot, and I'll still say it. In mathematics, positive or negative denotes direction. In accounting, positive or negative denotes direction. Positive means it's coming in, negative means it's going away. So, and in sports, positive means you're going downfield, negative means you're going towards the wrong goal. There we have that. So an angle theta is said to be in standard position if its vertex is on the origin. The initial side corresponds with the positive x-axis, like I had been saying. Oh, my L there got disappeared. And yeah, so then it's in standard position. So whether you're going in a positive direction or a negative direction, they all have the same orientation, where the zero, or the initial side, is this side, the x-axis, the positive x-axis. Now, when an angle is positive, either the terminal side will lie in one of the quadrants, the first quadrant, second, third, and fourth. It has taken me close to 20 years. Just one time I taught. When I was talking, and it was an Algebra 1 class. And I talked about the quadrants. When we talk about the quadrants, we use the Roman letters. The first quadrant, second quadrant, third quadrant, fourth quadrant. I did it in reverse order. And it's taken me 20 years to unlearn doing that just once. 1 year. It's crazy. Okay, so when the angle is in standard position, yeah, I already talked about that, didn't I? Okay, and so theta, we can talk about theta lying in, okay, so this angle here, theta lies in the fourth quadrant, right? If I had an angle over here, let's say this is approximately 150 degrees. So this angle here lies in the second quadrant, where this angle, to me, it looks to be about 30 degrees, lies in the first quadrant. And I don't have one in the third quadrant. The cardinal directions are 0 degrees, 90 degrees, 100 degrees, 270 degrees, and 0 degrees, or 360 degrees. The cardinal directions are not in a quadrant, just like the x-axis and the y-axis are not in any of the quadrants. They are boundary lines. like a boundary, like a fence line. If it's directly on the boundary line, it's not on either property. Okay, it's the dividing line between the properties. I got it in my hand, so. All right. 1 degree is 360th degree of revolution. A right angle is an angle of measure of 90 degrees or 1/4 revolution. A straight angle, 180 degrees or 1/2 of a revolution. 1 revolution is going around 360 degrees. All right, drawing these. Drawing those angles is not necessarily. So 135 degrees. Well, I know where 135 degrees is. I know it's over here. It's this angle. A negative 180. Well, here's 180, but I'm not going in a positive direction. I'm going in a negative direction. So that would be a negative 180 degrees. 90 degrees, yeah, that's up here. Boom, right here. Now notice 495. So we have 495 degrees. So that's going a full circle, and it's positive, so that means we're going this way. We're going to make a full circle. So we've gone 360 degrees. So what's left? What's left is another 135 degrees, right? 495. I've done the 360, so I could take that away. So now I still have 135 to go. Right, so that's going to bring me all the way over to here. So this was 495 degrees. Please notice that 135 and 495 have the same terminal side. If they have the same terminal side, then the properties those two angles have are the same. So any two angles with the same initial and terminal side have the same properties. As far as trig is concerned, they're the same angle. As far as motion is concerned, they are different angles. Because this one, you did a full circle before you hit the terminal side. What if it was 700 765 degrees? Well, I'd have to go around the circle twice, because going around twice is 720. So let me erase some of this now. So if I go around twice, here is 360, and then I go around again, so that's 720. So 720, I take away from, so I've gone 720 degrees, so that means I have 45 more degrees to go, which is right here. So this would end up being, there, which is the 765 degrees, which is the same as 45 degrees. Now, as far as doing any kind of calculations with it, it's the same as doing all the calculations with 45. But distance-wise, it's different because you have to go 360 degrees twice, and then, let's see, okay, you go it twice, and then you do the 45. or you could have wound up over here somewhere. So it just depends upon what's going on with the angles. And so, yeah, so they did it. And oh, by the way, you don't need to ask me for the PowerPoint because I'm not finished building the PowerPoint, but once I do that, it will be in the files. And there'll be it'll just be a separate item in the files that you can access at any time. You can either download it or just access it through your computer there, through the internet. And then the negative 180, yeah, I had done that where we went this way. And then 90 degrees, the 90-degree angle, so fourth of a revolution. And this consists of one complete revolution followed by a rotation to 135. So it goes around once and then ends up there. One counterclockwise revolution is 360 degrees. Yeah, I already discussed that earlier. A degree is 60 minutes and 1 minute is 60 seconds. And so now converting. Now, converting between degrees, minutes, and seconds to so we have 65 degrees. And then 9 minutes. Yeah. 9 minutes and 17 seconds. All right, we convert going this way. So 17 seconds. If I divide 17 by 60, that will give me a decimal of minutes. Yeah, since I don't have my phone, I don't have a calculator. Otherwise, I would do this. Can someone do that divide for me and post it in, either say it or post it in the chat? Oh, and that reminds me, calculators. The school, the department says you need a graphing calculator. I do not require a graphing calculator. I require a scientific calculator. I'm used to the TI products. So the TI scientific calculators, I can't remember the numbers on them. TI 30? Yeah, TI 30A, I think it is. And they have several different models. The basic model costs around $10 at Walmart. And you can get them that have much higher, a lot of bells and whistles in it. And they can cost up to $25, $30, depending upon where you buy them. All you need is the basic model. And I don't remember what it's called. That's the one I have and I use it all the time. I just didn't bring any of those with me today. And Casio, their scientific calculators, I think it begins with an FS something, I don't know, and then a bunch of numbers. Their numbering system, their naming system is even more confusing than TI's numbering system. So did someone do this for me? 9.283. And the 3 was repeating, correct? Because 17 is a prime number and you're dividing by a multiple of 3, so you're going to get a repeating decimal. So this converts to 65 degrees, 9.283 minutes. Now, this 9.283 divided by 60 gives us the number of degrees in decimal form. So if you do this division, you'll get another decimal number, round it down to where it starts repeating. So the last digit will either be a 3, 6, or 7, depending upon how it goes. Oh, and thank you, Esmeralda, for doing that earlier. Is my microphone picking up all my comments? Okay. Can someone do this division for me, please? .14154. And how? What kind of repeating numbers is it down here? 94. Okay, so if there was a 7 here, then it would be 1.55. If you rounded it to 3 decimal places. If you rounded it to 4 decimal places, then it'd be 1.547. If you went to 4 decimal places, but typically we're just going to go to the 3 decimal places. And so I should use approximately instead of equals. So this is 65 degrees point 1547. I'm going to go ahead and go to 4 decimal places. Now, unless you're specifically told the number of decimal places, I'll go to 3 or 4, depending upon the number. But in the MyLab, they will ask you 2 or 3 decimal places, sometimes 4. The most common is 3 decimal places. Every now and again, they'll go to 4, sometimes 5, but and sometimes 2. Sometimes they just go to 1. I don't know. It's just arbitrary how they do it. So, all right. Now to convert this to degrees, this was A. So hopefully I won't erase that one. So you're dividing the number. You go to the smallest unit shown and you divide by 60 and then tack that onto the number before, and then divide by 60 and divide and add that, tack that to the number before. So you get the decimal number. Now, if you're given a decimal number, and they gave us what? 32.479? 32.479 degrees. Okay. So the 0.4979 is in degrees, but I want to convert that to minutes. So I'm going to multiply by minutes. 60 degrees, 60 minutes, not 6. So 60 times 0.479. This is going to be close to 30 minutes because it's just under 0.5, and 0.5 is 30 minutes. So did someone multiply this out? 28.74. 28.74 minutes. So this is approximately 32 degrees, 28.74 minutes. Now, the 0.74 is in minutes, and I want to convert it to seconds. So the decimal part is the next unit down, right? The decimal part is the next unit down. So the 0.479 is the degrees, and it includes the minutes, and it includes the seconds. And the 0.74 is the seconds. So I need to multiply by 60 seconds. So it's 0.74 number of seconds. This is about a fourth, so this is around 45 seconds. So what is it? Did someone do this auto? 44.4. So this becomes 32 degrees, 28 minutes, and 44.4 seconds. Do they have us do a third one? No. You know what? They do it different than I do. Yeah, where I did the conversion a unit as a time, they kind of tried to do it all at once. And then they just add everything together. Yeah. It takes 360 seconds to make 1 degree. No, 3,600 seconds to make 1 degree. So instead of dividing this by 60 and then adding that to the 9 and then dividing that by 60, they went ahead and divided this by 60 and the 9 by 60 and divided the 17 by 360. I mean, 3,600 and added those together. I just like to do it piecemeal because I make fewer mistakes that way. Now, if you want to do it the way they do it, I have no issue with that. Okay, there's more than one way to skin a cat. Okay, there's a correct way, my way, and then all the other ways. But yeah, no, I don't test you on can you do it my way. But if you choose to do it a different way, then I need you to explain to me why you're doing it that way and how come you know to do it that way before a test. Okay, I had a student doing something a certain way on a certain type of problem that wasn't, on a second degree problem, she did it this way. On a third and or higher degree problem, she did it the way I did it in class. Because the way she was doing it on second degree problems only worked on second degree problems, which I didn't, once she explained it to me and I understood the process, I didn't have a problem with it, so. Okay. Now. Yeah. So yeah, this way they did it the way I was doing it. They multiply that out. And then they multiplied to get that. And then the 0.74, they multiplied that. Now, they did it more rigorously than I did. I was doing the same thing, only I took it out of the problem. So that this is 32 degrees plus, and then this would be 32 degrees plus the 28 degrees plus, right? But I just did it piecemeal rather than doing the formal way of doing it. But you get the same place. Oh, come on, you stupid machine. There we go. Now, arc length. Arc length. What is arc length? Arc length here I have an angle. Or here I have a circle. I should have drawn the circle first. And we're talking about this angle here. The arc length, and here I have a distance which is r, the radius of the circle. The arc length is the length of this portion of the circle. So the circle of radius r and a central angle of theta degrees, so theta could be there, or you could go all the way around over to here. It's just whatever theta is times the radius. Theta times r, or r, they did r theta. So S is the arc length, I don't know why they use S, equals r theta. Why? Well, because it's a portion of the circle. That's why. Right? The entire circle here, right, is 2 pi r. Right? But now we're just dealing with part of the circle. 2 pi is the entire circle. Well, this portion of the circle is theta over 2 pi. So if I do theta over 2 pi times 2 pi r, right? Because this is the portion of the circle I want. So the 2 pi's go to 1, and that's going to be 0, I mean, theta r, or r theta. So that's how come we say it's r theta. All right, so we have the arc The radius is 4 meters. And the central angle is 0.75 radians. So theta is 0.75 radians, which means it's a portion of pi. And R is 4 meters. So the length is 0.75 times 4, which is, what is that, 3.5 meters? Is that right? Yeah. All right. So this formula for arc length is when theta is in radians. Radians is using the pi measure, where degrees is the degrees. There are some instructors, when they talk about degrees, they don't use the degree symbol. I try to use it all the time, and I expect you to try to use it all the time. On homeworks, on exams, the work for exams, if you don't use the degree symbol consistently, then you'll lose points. Because this is notation. 74 what? 74 elephants? Yeah, so you need to tell me what it is. You know, if it's in radians, then you would say radians, which is more than one complete circuit of the circle, because the circuit of the circle is 6 point what? 28 something. 28 and 2 decimal place to 2 decimal place. 283 or 3 decimal places. Okay. So when we're talking about arc length, the formula for arc length is in radians. Theta radians. 3 meters. I was wrong. That's what I get for not doing the calculations correctly. That's 3/4. Okay, yeah, okay. The way, such a dope. I do better when I convert this to a fraction. I would have done that better. Okay. So 1 revolution is 2 pi radians. Half a revolution is 180 degrees, which is pi radians. 1 degree equals pi over 180 radians. 1 radian is 180 divided by pi. Okay. So those are your conversions from degrees to radians and radians to degrees. If you're going from radians to degrees, you're wanting to get rid of pi. If you're going from degrees to radians, you want to put pi in the number. Okay, so X number of degrees times pi over 180 gives us radians. gives us y radians. Okay, so if we go back the other way, y radians, and this, whatever this number is, will have pi in it. Well, to go from radians to degrees, I want to take the pi out of it. So I'm going to multiply by 180 over pi, which takes the pi out of the number and converts it to x degrees. Pi over 180 degrees, that should be degrees on there, and 180 degrees over pi. These are what are called unit fractions. You've used unit fractions since middle school and possibly before. Unit fractions is how I convert 4/3 to 28/21. This is a unit fraction. It equals 1. They all equal 1. Because the unit on the top is the same as the units on the bottom, they're just in different units. This is in radians and this is in degrees. 1 pi radian is the same as 180 degrees. So if I divide the pi by 180, I get 1. If I divide the 180 by pi, I get 1, and I'm outside my viewing range, aren't I? So depending upon which direction I do the divide, I still get 1, and that's what these are. Okay. And then with radians, usually write it as RAD, rad. But anyway. So convert each angle to degrees to radians and vice versa. And we've gone way over time. Yeah, we've gone, what is it? 15 minutes over time. I apologize for that. Please, if I go over, I don't have my watch. I mean, I have my watch, but I don't have a timer set in it. I meant to have a set timers to catch everything so we don't have what just happened happen. If I'm dangerously getting close to time and it doesn't look like I'm gonna wrap things up soon, don't post it in the chat. Just unmute yourself and say, Mr. Reed, we're at time. And so, yeah. So if you have any questions, I still am working on getting everything up and going. So don't hesitate to send me an email. I will respond as quickly as I can, tell you I'm getting there, or it's being done, or whatever. So. Bye.
Well, today's
Y'all on
lecture be
Wednesday.
posted.
And I'm going to end it here.